This is Dr. Christopher Sernaque hosting episode 7 of season 6 of the Current Topics in Science podcast. This podcast will address breaking scientific news in light of the origins debate and host interviews with scientists. Today we'll be covering a fraction of some of the amazingly cool stuff humans have sent into space and about how God intelligently designed the Earth's atmosphere. This podcast is available on the following platforms: iTunes, Audible, Google Podcasts, Spotify, and iHeartRadio. Video recordings of the podcast will be uploaded to YouTube. Enjoy the podcast. Have you ever heard music that was so awful that it was amazing? Like a fusion of jazz and funk called junk? Besides the Robots fans who understood that reference, for the rest of you, I'm going to be talking about all the incredible stuff that we have sent to space. Human ingenuity has proudly sent telescopes, satellites, space centers galore into space. Although, as Tom Hanks might say, Houston, we have a problem. Specifically with space junk. According to Professor Jake Abbott, a mechanical engineer professor at the University of Utah, we have a big space junk problem that's sort of off everyone's radar, pun intended. That's why he's developed an omni-magnet robot. Professor Abbott plans on using the omni-magnet robot to slow the debris in space down and cause it to burn up in orbit. He says, basically, we figured out a way to model the forces and torques that the spinning magnets create on pieces of aluminum and other metals that aren't magnetic, he said. Then, using math, we basically figure out what all the different magnets should do to make that thing move the way we want it to move. Professor Abbott and his team plan on having the robot in space within the next couple of years. And on that note, Professor Abbott's robot is not the only thing in space. The New York Times describes the situation as the traffic jam in low Earth orbit. There's the Chinese International Space Station. There's the 6-wheeled rover from India that was sent to explore the lunar South Pole where scientists think deep craters may hold ice. There's the USA's eye-in-the-sky satellites that are used for geospatial intelligence by the United States government. There's a robot in space from China called the Neo-1 that is designed to vaporize and sort an asteroid-like material in orbit. Now, if you're interested in seeing more of these amazing examples of ingenuity, please check out the awesome interactive on the New York Times as it takes you through the rest of the amazing machines we've sent beyond our atmosphere. Speaking of our atmosphere, what is it? Is it sort of like the gateway that all these rockets, shuttles, and satellites need to get to the stars? Or is it more like a dome that goes over a container? According to chemist Russell Grigg, although you can't see the atmosphere, it's very important because it contains the air we need to breathe to live. Also, birds need it so they can have somewhere to fly, otherwise they'd never get off the ground. The air is made up of mainly nitrogen, some oxygen, and a tiny amount of other gases such as carbon dioxide. These are in just the right amounts. If there were a lot more oxygen, then a single spark could set the world on fire. If there were a lot more nitrogen, we would suffocate. Carbon dioxide is essential for plants to live, but it's deadly to humans in large quantities. Earth's atmosphere has only a tiny amount of carbon dioxide, which is plenty for all the plants because they use it very efficiently, and this small amount is harmless for us. Dr. Mark Harwood, whose postgraduate studies were focused on radio telescopes and computer techniques for antenna design and measurement, has an excellent description of the Earth's atmosphere. He says, consisting of 78% nitrogen and 21% oxygen, Earth's atmosphere forms a thin sheath around the globe, held there by gravity, protecting and nourishing life on the planet. The atmosphere is contained within about 100 kilometers or 60 miles of the Earth's surface, which is only about 1.5% of its radius, about the same proportions as the skin of an apple. Scattering the sun's light, the oxygen and nitrogen molecules produce a blue canopy, which permits us to normally see only the sun and moon by day. But at night, the atmosphere becomes transparent to reveal the planets and the stars. The atmosphere helps regulate the temperature of the Earth and transports water vapor to facilitate the hydraulic cycle of evaporation and precipitation, so rainfall and snow, etc., to distribute water around the Earth. The interaction between the energy radiated from the sun and the atmosphere influences the weather patterns around the world, which in turn influence living things. There are also multiple layers to the atmosphere, like the ozone layer. According to Andrew Sibley, a chartered meteorologist, the penetration of UV light is restricted by a layer of ozone high in the atmosphere. It lies within the stratosphere, an area of sky that starts from about 10 kilometers, so 6 miles, above the ground, extending upwards about another 40 kilometers or 25 miles. The ozone layer itself starts at about 15 kilometers in altitude to about 30 kilometers. Chemical reactions involving ozone prevent the energetic UV rays from reaching deeper into the layer just below, the troposphere, Earth's lowest atmospheric layer, and to the ground. However, much of the less energetic UVA light is permitted to reach the ground, where it aids photosynthesis and plant growth. Andrew goes on to describe the other layers by saying, much higher up, between 60 and 200 kilometers above the Earth, is the ionosphere, which filters out the powerful X-rays that come from the sun, particularly from solar flares, and also from deep space. The magnetosphere also protects the Earth from very high energy particles, mainly electrons and protons that come from the sun and cosmic rays. These particles are captured by the magnetic field and bounced back and forth between the polar regions, becoming visible as the awesome aurora light displays in the polar regions, Aurora Borealis in the north and Aurora Australis in the south. The atmosphere plays a vital role in our health as well because it allows the right amount of UVB to reach us, which is important because it enables us to generate vitamin D in our skin. Although we can get this important vitamin through eating such foods as oily fish or cod liver oil supplements, it largely comes through the action of sunlight on our skin. So it definitely sounds like King David was right when he said, "The heavens declare the glory of God, and the firmament sheweth his handiwork." To our listeners, thank you very much for taking the time to learn with us on current topics in science, where scientific discoveries are examined in light of the origins issue. You can find the articles referenced in this podcast episode, along with more evidence for the atmosphere's design and a link to the Christ Jesus Ministries merch store in the description. Please share and subscribe to the Current Topics in Science podcast. It's available on iTunes, Audible, Google Podcasts, Spotify, and iHeartRadio. Thanks again for listening, and remember, the truth saves.